All right, so greetings. Welcome to Eureka Math Squared. This is grade 6, module 5. This is lesson number 4, which is real world triangle fun. Okay, so we're hanging out on page 61. And so let's not waste any time. Let's get going here. So we have Mr. Perez. He's building a fence to enclose a play area for his dog. All right, keep that dog in that play area, please, if you would. Anyway, so the enclosed area is in the shape of a triangle. So let's see, let's build a triangle here. Let's just draw one out. Triangle, sure, let's see. Little play area, we'll make it good and thick so the dog can't escape. How about a right triangle? Why not? Okay, so let's see the base and the height. We have a 48 meters and 32 meters. And typically your base and height, if you're going to calculate for area of a triangle, they have to be perpendicular to one another. Okay, so I'll make this guy the base. How about that? And I'll make this guy, let's see, this guy, GHT, the height. Sure, so perpendicular, notice that right angle here. These are perpendicular, they form a right angle. So we have a 48 meters over here. We have a 32 meters over here. And as in previous videos, we learned that, hey, the area of a triangle is really half that of the rectangle that's created, right? So if the area of the rectangle is a length times width, right? The triangle's half the size of that, right? So we need to take half of that. So we write this out a little bit different, right? So we want half of, right? Because that means to multiply half of, and we're going to use that base and height as if it was a length and a width. Okay, so there's that length and the width there, and we're taking half of it, so we're going to multiply that. In other words, divide it by 2. So let's go and let's get going here. So I like to write it all out using parentheses. So there's my 1/2, parentheses next to one another means automatic multiplication. There's my 48, and then my 32, like that. Now remember, if I was just finding the area of the rectangle, these would be my only two values I would care about. I would simply multiply those. But I want 1/2, thus the 1/2. Now I can mess around a little bit here. I can multiply these two first if I want. So area now is half of the 48, which is 24, right? And then multiply that by the 32. So I have a little 32, I have a little 24 off on the side. I'll have some fun over there. There's a little 12. Let's get that going there. There's a 4, there's a 6. I have an 8, a 6, and a 7. Okay, so 700, and I'll cruise on over here, a new line here. 768 meters measured in square units. Okay, so 768 square meters is the play area for this dog. Okay, now Ryan says that the play area can be a right triangle. Maybe it's an acute or maybe it's an obtuse triangle. Do I agree? Actually, I do agree because, like I said earlier, the base and the height, right, they just have to be perpendicular, that's all. So let's say the base is this guy over here and the height is this guy over here, right? And that would form a triangle that looks like this, right? So that is not a right triangle. The right triangle we already drew. This is an acute triangle, right? Acute angles, right? And the obtuse, right? Again, same thing. So let's say I have a base over here, and there's my base, and let's say my height's coming over here a little bit, right? Maybe it's on this side perpendicular. No, that would be the right. No, it doesn't matter. Let me put it on. Where could I put this guy to make him obtuse? Let me see. So the obtuse, I'm going to go that way. It goes right. Oh, I'm going to have that imaginary height. That's really what it is, right? My imaginary height's going to be height's going to be over here. Right, there's my base here. This would be then my height, right? And here's my perpendicular right there. Okay, so do I agree? Yes, I agree. Yes, right. The base and height must form a right angle, but can be imaginary. Can be imaginary, right? As it is in here, it's imaginary, right? It is not a side of the triangle. Over here, it's imaginary. It's not a side of the triangle. But over here, it is. Both are sides of the actual triangle. Okay, the base works over here, but not the height. That's imaginary. Here's the base, but here's the height. That's imaginary. And you can see they form 3 different variety of triangles. This one's obtuse, see? Obtuse angle. There he is. Okay, one more. How's this? So now we're building a bench. Why not? Is this the same guy? Mr. Roger? Maybe it's Mr. Ryan Sharma? I don't know. The bench fits into a corner. Okay, well, that tells me there's my corner. A right triangle. The top of the bench forms a right triangle. Okay. The bench is 2.5 feet long along one wall. So how about this one? 2.5 feet. How about right there? And then 4.25 feet along the other wall. How about that guy? So I don't even care about this one. Who cares, right? Because it's really about that rectangle, right, that is formed, taking 1/2 of it. Okay, so what is the area for the top of the bench? Okay, well, if it was a rectangle, I would simply take the 4 1/2, excuse me, the 4 1/4, and multiply it by the 2 1/2, and then take, or if it was just a rectangle, that's all I would need. But I want half of that because I want the triangle. So we're in fraction land here, lots of multiplication. So let's just spread this out in multiplication land with a fraction. So I'm going to turn everything into a fraction. See, 16 plus 1, how about a 17 over 4? And then multiply and add, how about a 5 over 2? And now we're feeling pretty good. Okay, so now all I have to do is multiply things out. I have a little 17 times 5, right? This guy times this guy. There's a 35, right? There's a 5, 6, 7, 8. So there's an 85 on the top. So far, so good. And then let's say 2 times 4 is 8. 8 times 2 is a 16. Okay, well, I can't leave that, so I'm going to drop down. And I'm going to knock that over and divide, right? Knock that over, see that? So I have a little 16 into 85. Okay, and that's going to go probably 5 times, let's see. 16 times 5, there's a 30, there's an 8. Okay, so there's a 0. How about a 5? How about an 80? Subtract and I get a 5. Cool. And that is my remainder over, or my numerator over my divisor of 16. So 5 and 5/16 feet squared, right? Squared, because we have only 2 units to deal with. There it is. So that is the area of the top of the bench. Okay. Okay, so a little area of the top of the bench. And there you have it. All right, folks. So I hope you enjoyed that and maybe learned a little something. Don't worry about it. It's fantastic. Math rules. Take care. Bye-bye.